In this video, I'm going to work our second example looking at data modeling and LINQ query techniques to process a data file. Alright, let's look at this data file. We are looking at a data file called dowjonesindex.data.txt, and this file has some stock price information for a bunch of companies. So it looks like this is a comma-separated value file. The first line is going to be the header information, and then we have all of the data. It looks like we have the first column has the quarter information, which looks like an integer value, number 1, number 2. Then comes the stock name. The stock name looks like a capitalized string of text. Then comes the date. The date looks like it's in the form month, day, year. Then we have some open, high, low, close prices. These are dollar values. They are decimal values with $ characters inside. And then we have some volume and percent changes and a bunch of other columns of data, dividends and so forth. All right, so this is what the data file looks like. It has many lines of this formatted data. Let's look at what the problem is asking us. So we are going to try to build an application that is allowing the user to do 2 searches against this data set. We want to let the user enter in a stock name, and we will search the data set against that stock name, and we want to determine what date did the highest opening value occur for that stock. So what was the date where the highest opening occurred? Next, we are going to try to let the user enter in a stock name, and we want to calculate and display the percentage of days where the close price was higher than the opening price. So if we count the number of days where that stock had a higher close versus just the total number of entries for that stock, we can calculate a percentage. So if I want to model this data here, I'll shrink it down a little bit. I want to model this data. I need to determine which components, which pieces of this data do I need to model. Well, for question 1, I need the name and the date and the opening value at a minimum. So the name is index 01, the date is index 2, and the open is index 3. So I need to model those 3 values. And I think that's it for question 1. For question 2, it says entering a stock name, we want the difference between close and opening prices. So I also want to pull off this close value, which is at index 0, 1, 2, 3, 4, 5, 6, if I were to read a line and split it into its pieces. So the stock name, the date, the open, and the close, those are really the key columns that we are concerned about with this data set. So if we are going to build a data model to model these stocks, those are the pieces I want to include in our data model. All right, let's get to work. Here we are starting with a blank form, and I'm going to add some components to this form to help me solve this task. First up, I'm going to grab a rich text box. The rich text box is going to allow me to output data. Next, I'm going to add a button, and this first button I'm going to set so that we're going to use it to load a file. Next comes 2 different queries we are running against this data set. So I'm going to add a button 2, which is going to do our query 1, and our button 3 is going to do our query 2. Where query 1 is looking for the highest opening date for a stock, and query 2 is finding the percentage of where the percentage of days where the closing price was higher than the opening. Now both query 1 and query 2 depend on the user entering in a stock value. So I need to also have a text box where the user can enter in a stock name, and let me give it a label so we can tell the user what to do. So we will say enter stock name, and we will try to spell it nicely. Okay. Do we have all the components we need? I think we need one more. We need the open file dialog. Open file dialog control will allow us to spawn the window that lets us search for a file. So I think we have all the pieces. Now we need to register the events to make this thing work. Well, the way I think I want to make this work is when you click the load, when we spawn our form, I'm going to disable our two query buttons. Once the user selects a valid file, we will enable the two query buttons. Also, in this case, I want to, because we're going to build a data model, we're going to extract the data from the file. Let's do the following. When we click on the load file option, let's not only choose a valid file from our computer, but when we choose the file, let's immediately read the file and strip all the values and create a data structure that contains the information of the file. So when we load the file up, not only are we going to open the file, but we are going to extract all the information right then and there. So when these query buttons pop up, the data should already be processed. I mean stored in our application. We just need to run our little LINQ queries against that data set. All right. If that makes sense, we will move forward. Let's get into the code here. For the load button, I'm going to register a click event called load data. I'll call it load file. In my query 1 button, I'm going to create a click event handler named query 1. And in my query 2 button, I'm going to create an event handler named query 2 that will respond to the clicks. And I think that's all we need to do from the design view. Now it's time to get to work on our coding. In this example, I'm going to build two public field variables, or well, they can be private. So two field variables. One for the file path, and then the other one for the list of stock data. So as I extract, I want to create a list that holds each stock that is listed in our data file. So before I can do that, I need to create my class that will act as a model for our data. So I'm going to, let's add the class next. I'm going to say project, add a class. We are modeling stock data here. These are stocks. So I'm going to name this stock, this class stock. Now this class, we said we needed 4 pieces. We needed a name, a date, an open value, and a close value. So I'm just going to create those 4 pieces. I'm going to make a public string name property and make it auto implemented, no protection. I'm going to make a public string date property, auto implemented, no protection. I'm going to make a public double open value, no protection. A public double close value, no protection. And then I'm going to make a parameterized constructor, public stock. If we pass in a string name, a string date, a double open, a double close value, then I'm going to assign these values into my properties. Name is equal to name, date is equal to date, open, open, close, close. So all I'm doing is instantiating my stock, creating my stock object with the 4 values I passed into it. Now the reason I'm creating this data model is that I can then later use LINQ queries to filter on all of these components. Okay? So this is our model that represents a stock object with data populated from our data file. Okay. Let's go back to our code. Now we can make our 2 field variables. I'm going to make a private string file path variable, which will hold the path to the file. And I'm going to make a private list of stock values, and I'm going to call this stocks. So 2 data members of our class. In our constructor, let's set up let's initialize our field variables. So I'm going to set the file path equal to an empty string, and I'm going to instantiate our stocks list. So we're going to create a new list that contains stock objects, and now the list is empty and ready to go. So build the empty list. I'm also going to do 2 more pieces. I'm going to take my button 2 and disable it, and take my button 3 and disable it. So now I can't run my queries. I can't click on those buttons and run my queries until I enable them after reading in the file. So let's do load file next. So when the user clicks to load a file, we are going to use a stream reader to try to make a read connection to that file. And the stream reader is inside the system.io namespace. So I need to add that system.io namespace. And now I can create my stream reader connection. I'm going to use the alternate syntax here. I'm going to use a using syntax. And I'm going to create a stream reader object called, so stream reader is equal to a new stream reader object connected to the file path. And as a reminder, the using syntax is going to open the file. Var is just going to be a stream reader. It's a shortcut to get that stream reader data type. SR is a stream reader object. I'm opening the file inside my using parentheses. The file will be open while I'm inside this code block, and the file will close automatically when we get to the end of that code block. Okay, so we're opening the file here. Now we're going to read each line in the file. So while we haven't reached the end of stream, so while not at the end, I'm going to read each line. So read line. So read each line. And now the work I want to do is I want to strip this line to its pieces, pull the 4 values that I consider important, and build a stock object with those pieces, and then put that stock object into our stocks list. So let's do that. Now as a reminder, here's what our data set looks like. Stock name is at index 1, the date is at index 2, open at index 3, and close at index 6. So those are the 4 pieces I want to pull off. When I pull off the stock name and stock date, they are string values inside the text file, so I just pull them directly. But when I pull off the open and close values, I need to parse that string value into a double, and I also have to try to replace or remove that $sign. So I'm gonna do those steps coming up. And then finally, we have this header line that we need to ignore. Okay, I can process all of these good values, but we want to ignore the line that starts with the text, the string value quarter. So let's make this happen. So after I read the line, I'm going to say, well, if the line starts with quarter, well, that's the title line, so I'm going to continue. We're going to ignore this line. If it doesn't start with quarter, then I'm going to split the line into its pieces. So I'm going to create a string array named data, set it equal to line.split on the comma. And I'm going to create a variable just to hold each of these main pieces. I don't have to do this, but I am. So I'm going to say string name is equal to data at index 1. I'm going to pull off that name value. The date we said was at data at index 2. For the open value, we said that was at data at index 3, but data at index 3 needed some work. So one thing we need to do is we can call the replace method, and I'm going to replace the $sign with an empty string. This is going to return the string value with the $sign removed. Now that string value with the $sign removed should be ready to parse. So I'm going to wrap this in a double dot parse method. So what we are doing here is removing the $sign and parsing to double. That's the work I'm doing here. I'm removing the $sign, replacing it with an empty string, and then parsing that value into a double data type. And for our close, we're going to do exactly the same thing, except now we're looking at data at index 6 on the line. We'll go ahead and still replace the $sign with an empty string. So I split the data, I pulled off the 4 values that are important to me. Now let's create a stock object. So I'm going to say stock s is equal to a new stock object, and I'm going to initialize this stock object with all of the values I just extracted. So I'm going to pass that name, that date, that open, that close value right into my constructor, build this stock object, and now s is a stock type with the name, date, open, and close values I just pulled from this line. So we're going to create a stock object from line data, and then the last step will be add this data to our list. So I'm going to say stocks.add s. Again, stocks is a list that is a data member of the class. I want this list to persist throughout the life of my form application. And then I think that's it. Oh well, there is one more thing I want to do. If the user, when the user chooses a file, so when they load a file, wait, I'm not using the stream reader at all here, or the open file dialog at all. Boo, bad example here. When the user clicks load file, I have to do a little bit of work here. I have to say, if the open file dialog 1 show dialog method returns a dialog result OK, then I can do this work. Okay, then I can read, make a connection to the file, pull all the data, add it to our list. All right. Only under that condition, only under the condition that the user chose a file from our open file dialog. If they did, my file path is going to be equal to the open file dialog 1.filename property. So I forgot I needed to strip the file name from the open file dialog. Then I can use it to open my file path. And then I'm going to do one more thing. What if we went to load the file again? I don't want to add duplicate data to my stocks list. You know, our list can just keep expanding. So what I'm going to do is every time I go to open a new file, I'm going to grab the current file path from our open file dialog, and I'm going to take my stocks list and clear it. So erase all values previously stored. This way, I always start with a nice fresh empty stocks list before I open the file to read it. Read each line, ignore the first, split the line into its pieces, pull off the important data pieces, clean a couple values, build a stock object with those values, add that stock object to our list. By the time we get through the file, every line in the text file will represent an object inside the stocks list. Okay? So we're not doing any logical processing here. We're just creating a data set right here. We're creating this data set so that we can then query against it. So alright, so if the dialog result was okay, we strip the data, and we need to make our buttons visible so we can query them. So I'm going to say button 2 enabled is true, button 3 enabled is true. Okay, I think we're ready to build our LINQ queries. Alright, for each of our LINQ queries, these buttons are only enabled. Oh, let me do one last piece. Sorry about this. If the user chose a good file and clicked OK, Then we stripped the data from the file, enabled our buttons. There's still the option that they did not pick a valid file. So in this case, I'm going to set the file path equal to the empty string and disable both of my buttons. Just trying to be complete here. Now I think we are ready for our LINQ queries. All right, let me pull the text that we're trying to do here. So this is the work for this query. So allow the user to enter in a stock name. We have a text box for that. And find the date where the highest opening occurred for that stock. Okay. Since I have another user input, I need to protect that user input against potentially bad values. So first we're going to pull the user stock input. So I'm going to say if the textbox1.text property, and I'm going to call the trim method. The trim method removes any white space characters around the text. So I'm going to say if this is equal to an empty string, that means the user did not enter any meaningful search term. So I'm going to create a message box that says, please enter a stock name. Then I'm going to clear out any bad text that might have been entered, set the focus to this text box, and return. We're done. So this is protecting us against the user not entering a good term, search term. And if they did enter a good search term, then I'm going to create a variable called user input and set it equal to textbox1.text. So if they entered something at all, I'm going to grab that value, and now we have a stock name to compare against. And all the stock names in our file are uppercase. So if I want to get fancy, I could say take the whatever text was entered into the text box and let's make it uppercase. So I'm going to call the toUpperString method at the end of the text. So make user input uppercase. Okay. Now it's time for us to write our query to solve this problem. Let's see if we can do it in one LINQ query. So I'm going to say var query is equal to, first of all, I want to select all the stocks in my stocks list. So from stock in stocks, stocks is my list of stock types. So the variable stock represents a stock data type, if that makes sense. For each thing in my collection, well, this thing is a stock object. All right, from each stock in stocks, I'm going to do a filter now. I want to match on where the stock name is equal to the user input. Okay, so I want to filter my results down so that they only return, I'm only looking at the lines of code or the stock objects where the name matches what I'm looking for. Okay. Okay, so now I need to find the highest opening. So I need to maybe I need to sort my results high to low. So I can order by the stock.open price, and high to low is I want to order in descending order. Ascending order is low to high, descending is high to low. Okay, and in this query I want to select each stock object. So let me walk through this query. For everything in my stocks list, for all the stocks in my stocks list where the name property matches the user input, I want to grab those stocks. So I'm just grabbing every single stock value, every single stock line with a matching name. I'm going to sort those names by their open value in descending order. So the first stock in this query should have the highest opening value. All right. What I can do is, if I only want to grab the highest value of the set, this query contains all the stocks where the names match. But if I only want the top one, I can wrap my query inside a pair of parentheses, and there are several methods I can call against this query set. And one of them is called first or default. First or default returns the first element of the sequence, or a default value if the sequence contains no elements. The query will be null if there were no matches. So I'm going to take the result of my query, only grab the first top element, which should be the stock with the highest opening value. Let's see if this works. So if the query that is returned is equal to a null value, that means there were no results found. So I can go to my rich text box text property and say no matches found. Otherwise, this query result should have the matching stock with the highest opening value. Now, because we are selecting stock objects into our query, and since this first or default is only pulling the first stock object, my data type for my query should be a stock data type. And if I hover over it, it says it is a stock data type. That means my query variable here should have a name property, a close property, a date property, etc. So if I say richTextBox1.text is equal to string.format, I'm going to say this stock, I want to insert the name first, had a opening high of this value, that's the opening value, on this date, which is the date. And I'm going to insert my query name, my query.open, and my query.date. Okay. So let's see if we are okay with this. Shrink it down a little. Okay. So if this query returned a result, that query is a stock, so it has a name property, open property, date property. I'm just extracting the appropriate values from the highest stock and printing it. So I know this is probably very confusing for many of you. The LINQ query language is very powerful, but it takes some practice and it takes some getting used to. Okay. All right. We will test this out in a moment. Well, let's test it out now. It's late, and there are always chances that I'm going to make bugs as it gets later. All right, we're going to load a file. I'm going to choose my Dow Jones file. My buttons are enable. If I enter in nothing and I try to run a query, my query 1, it tells me to enter a stock name. If I enter in a stock that doesn't exist and run my query, it tells me no matches were found. Okay, so this part of my logic is working. If I enter a stock like IBM, run my query, it found the result. It said IBM had an opening high of $172 on 5/6/2011. And we can go back into our data set and try to verify. How about DIS? We got a result. McDonald's, MCD, we get a result. So looks like our query 1 is working. If I enter a lowercase MCD, or let's do lowercase AA, we're still matching because we put that little filter to capitalize the user input before the match. All right, so far so good. Let's look at our second problem here. So our second query is asking for the following. Enter in the name of a stock, calculate and display the percentage of days where the close price was higher than the opening price. All right. So let's look at this or think about this. In this case, I need count values, right? I want the number of stocks where the close is higher than the open, so that's a count operation. And I need the total number of matches for that stock. So that's two counter variables, or two count operations. So if I have those two count values, I can calculate the percentage. So let's try to build our queries here. So I'm going to create a query called number of higher close. And let's see if we can come up with a query that produces a single count value that matches our request. So let's start off with from stock in stocks. Stocks is our list. Stock is an object in the list. Okay, I want to filter on matching names again. So let's go ahead and grab our user input text box protection and dump that into our second query. So we're protecting against user input. If it's good, we're stripping it and making it uppercase. Now, we want to find all the stocks in our list where the stock name matches our user input, just like we did before. All right, and we only want to count the stocks where the closing price is higher than the opening price. So this is a filtering operation. So I'm going to say and stock close is greater than stock open. Okay, let me make this a little more readable. So I'm filtering on two conditions here. These both have to be true. The stock name has to match, and the closing price has to be higher than the opening price. All right. So if that is the case, I want to select those stocks. So select stock. This query is going to return a number of stocks that match in this condition. Now, since I don't care about the stocks themselves, I only care about how many there are. I'm going to wrap my query, and at the end, I'm going to call the count method. The count method returns the number of elements in this sequence. So I'm going to find how many stocks match on name and have a higher closing than opening, grab those stocks and count them, and I'm going to dump that count into this variable. So this variable should be an integer variable. So if I hover over it, we see it is an int. That's half the battle. Let's get our next piece. I'm going to say var total number of matches. So I can say from stock in stocks, where the stock name is equal to user input. That's my only filter I'm using this time. I want to select all of those stocks. Find every stock in my list where the name matches the user input. And again, I just want the count. I just want the total. So I'm going to wrap this query and call the count method from it, and I should get the total number of matches. Now we'll just spit out the results. I'm going to say rich textbox1.text is, well, we need to check to see if there are no matches, right? There's a chance that there are no matches. So I'm going to say if the total number of matches is equal to 0, then I'm going to display no matches found. Otherwise, we will output some text. We'll say rich text box equals string.format. This stock had a higher close. This percentage, I'll format this as a percentage with 1 decimal of the days. And I'm going to insert the stock name, which is user input. And then the percentage is going to be the number of higher close divided by the total number of matches. And these are both integer variables, so I need to make sure I cast one to a double. So we save precision, and there we go. So our query to find this is just right here. Find the number of stocks that have a higher close than open that match on the name versus the total number of stocks that just match on the name. All right, let's test this out. Okay, we will load our file, Dow Jones. I'm going to pick a stock that doesn't exist, try to run query 2, and it says no matches found. So our protection is working here. Now let's enter some stocks we know exist, IBM. So IBM had a higher close 60% of the days. How about Bank of America? Ooh, not very good. It only had a higher closing value 28% of the days. What about McDonald's? McDonald's is doing pretty well. It had a higher close 64% of the days. So all right, I hope this helps illustrate kind of some of the ways we can use data modeling and LINQ queries to process data files.